Keith, why don't you walk us through this Massachusetts example? Is this that building that we were talking about earlier, or is this a different project?
No, this is more. This is more of the first project when we're looking at the gas-fired chiller as an example. But what I wanted to really point out is the four-pipe system, in that you have a cold water source that is going out to the different air handlers, then being returned back after it's absorbed the energy, and then the heat recovery chiller then turning around and creating the hot water that goes back out to the air handlers in the space and in the other rooms. That you just can keep connecting these rooms for the entire facility together, so you can see how it is easy to daisy chain all these elements together and just take individual room control and decide how much cooling and how much hot water you need for it to go on. And then on the other side of the thing is the excess energy. You have the different types of coolers, the fluid cooler, the adiabatic cooling towers that become the source of the rejection, and they have each of their own efficiencies and usabilities. I mean, when you look at these water systems, somebody has to maintain the full system plan. And you can't just say, I'm going to install it, and 20 years later, I will do no maintenance. There's a lot of other considerations, such as maintaining the glycol water concentration mix. If you don't do that, you're going to have things freeze up in the winter in Massachusetts, and it's a disaster. And so there's maintenance issues to get involved with these different type of products. And it would really apply to all of the HVAC in the grow room. If you don't have access to a good service contractor at a high level, I'm not talking about a residential one, you're going to have troubles over the long haul of your facility.